Well, hello everybody, welcome to this new tutorial. In this tutorial series, about like 3 videos, we're gonna learn how to implement machine learning in Grasshopper. Right now, machine learning is something like very trendy. There are many people trying to figure out how to actually use and also find a purpose on why how machine learning will be useful for a design workflow. In this first video, I will show you first how to install some tools and how to use some very interesting tools for doing some machine learning. The first one, or basically like the main tool that I will show you, is this one called Runway ML. This is a very nice tool that was created by people at NYU, the ITP Interactive Telecommunications program at NYU. They created this awesome application that is a free application that you can use it, and basically it works as a black box for you to use like most of the machine learning models that are out there for, let's say, image manipulation purposes. So for this tutorial, you want to download this. This is a tool that is compiled in a way using, I think, Electron. So basically it allows you to distribute your application or use it as a user in operating systems such as Mac OS, Windows, or Linux. So that is like actually pretty cool. So this is why this tutorial I'm doing it on Mac OS instead of Windows. So I know that many people use Mac, so this is a good chance also to to show that workflow in a different operating system. So after you download Runway ML, it will ask you to create an account, because the way it works that I will explain, it processes everything from the cloud. It has a cost, it's really cheap, and initially you will get some credits that are $10 that are enough to try a lot of things. So don't worry about that, it's like really cheap. You can put like, I think, from $5, and that gives you a lot of time on the cloud to process your models. So you will see a window like this where it will show you like 3 different options. First, like to browse models that I will explain. Open workspaces. I will explain what a workspace is, and also it gives you a new option that was added recently to train your own machine learning models. So imagine, like even like 6 months or 1 year ago, this was almost impossible. This is actually pretty cool, because if you don't know how to code, for example, how to use Python, you're kind of lost. If you want to learn or even understand what machine learning is or how it works, here you don't need it. And probably this will be like the future with most of the tools that are being developed right now, or models like to do predictions. If you take a class, for example, in computer science, of course you will understand what's in the back and you can be like a master. But if you don't have the time, or you don't want to get into like hardcore coding or math to understand things, we have tools like this. So first things first, I will go to browse models, and it will open the application, which has a really cool interface. You'll see I have some things here. Shows the recently used models. So you have models that are open source that can do a lot of things. You can sort the models from, for example, like most populars, like the new models added, or alphabetically order models. So for now, I will show you, you can do like new, and also you can sort or you can filter by data type. So basically what you want to produce, or what you want to use as an input for data. So basically all of the way this works is that you always input some data, numbers, words, images, videos, and you get something out. It could be a prediction, like a text, or it could be another image, or it could be, I don't know, like a skeleton model with your pose estimation, or things like that. Or you can also browse by category. So for example, the most popular one right now is StyleGAN. It's a generative adversarial network. You have image synthesis, motion capture, text-based models, recognition, post-processing, style transfer, workflow. In this first video, before going into Grasshopper, I will show you some really cool things that could be helpful for you. So for example, let's check first. So you can browse here. You can find like a lot of models. Actually, this is and things that are look like really stupid. So for example, like a pizza generator, which is like actually quite stupid, dumb. But what's behind this is interesting, especially for designer architecture, because now with the option of training your models, you can train a machine learning model not to produce pizza, but to produce, for example, floor plans, to produce perspectives or things like that. If you look around, basically you will have a description. If you go to the learn more, it tells you what it is. It tells you who is the publisher of this model, the guy in the company, Runway, who worked on this, the attributions. Of course, these models has like some licenses or copyrights. It tells you like the weight of the size of the model, what it does. It also has information about how to implement it on your own if you're proficient in coding, to the paper or the GitHub repository where you can find more information about that. So let's go back to the browse models, and there are some really nice tools. I mean, I was saying that you have like pizza generators, but also you have cool things such as edge detection, for example. If you have a picture and if you want to find the edges, it uses this really cool machine learning model. I clicked on the wrong part. So if we go to learn more, basically this has a new technique for detecting edges. So you can see these are like really clean. If you want to extract, for example, or vectorize an image, you can use this. Some other cool models are this one, image super resolution for 2x, 3x, and 4x upsampling. So let's say you find a picture on the internet and that picture has a really low resolution, but you want it like bigger to put it on a drawing or things like that. You can upscale this using machine learning to get like really good resolutions. I mean, changing the size of an image from like, I don't know, enlarging like 2x is also like, is already like really cool. You have like several models like that. You have like the upscale in real time. You have models to enhance the lighting of your images. You have image segmentation. This is also like really cool. So for example, you have a floor plan or you have an aerial picture and you want to do some segmentation to separate, for example, to analyze. Give me, for example, the information of colors in a better way, like understanding the content. Some people will say like, oh, this is like using like a filter in Photoshop. Basically, this is what this model is doing, is understanding the context. It understands that it needs to generate a mask from the sky colors to give you all the pixels that belong to that category, sky, for example, or trees or animals or things like that. So that's actually pretty cool. what else? So we can learn how to use it. Well, you have like how to create like motion, how to recognize like face landmarks. If you're doing like projects with interaction, you can identify and segment objects in real time from a video feed, or for example use like pose estimation. You can generate realistic images from a drawing tool. That's also like really cool. Super scale your images. Again, a lot of models like this. Colorization of pictures. So for example, you have a black and white picture, like a really old picture, and if you want to generate this image in colorize this image, you can do it. It will not the real thing, but it's really cool to see like old pictures becoming like full color with this technique. Extracting semantic maps. For example, predicting depth. This is like pretty similar to what your phone is doing when it's like applying blurring filters for the background. A lot of models. This is also like really cool, how to cut objects from images. So if you want to extract only people, for example, or cars, you can do it with this mask RCNN. It uses like convolutional neural networks to do that. And things like that. So how do you start? You can go to the workspaces part. You see I have some here, and you can do this from, you can do this in like several ways. The first one is to just choose a model. So let's use the one I was talking about before, about, find which one was it. It's a really cool model. Let's try this, the generate realistic images. So you can click here on add to workspace, and you will create a new workspace that you can rename. Or you can start by just saying, we'll close this workspace. There's an option to create a new workspace that I missed. I don't know where it is. Anyway, if you add this to the workspace, it will ask you for a an input. In this case, you can provide a file with a predefined set of masks, or you can use segmentation. So when you have here segmentation, you can start painting. Just like this. Here you can select, for example, the color, the brush size. So here, for example, it's giving you categories on the right part. Let me erase everything clear. So for example, I want to let's do a road. If they have something like that. Have like many categories, as you can see. So let's say grass. Let's paint some grass. The tool is not like very advanced. You can do this in Photoshop using the right colors, of course. So let's say I want to paint this like grass. Maybe we can paint some rocks. Brush. Paint some rocks here. Rocks here. Rocks here. Let's do like more like that. And see, they have something like sky. Should be something like sky or clouds. Sky. Let's paint this guy here. It's already that color. Clouds maybe. They have a search, so cloud. Let's paint some clouds. Like this, like this. And now, basically, we need to process this. The output will show an image according to the mask that I just painted. Basically, it will try to fill the content. It will try to fill all this color with cloud information, all this color with rock information, and all this color with grass information. It will use this model, this machine learning that is located in a server. And if you do run remotely, it will start processing this, and it shows me the image that's actually pretty cool. If you want to create like skies for your renderings, you can do it, and you can then download this image. This is now being processed on the cloud. So if I stop this and if I click on show advanced options, it tells you, it asks you, okay, you can run this locally, but it asks you to install something else that is called Docker. For now, we're not going to go into that because it gets like a little bit complicated. But if you're familiar with Docker, you can install it on your system, and basically it would download the full model that is like, I don't know, like approximately, I guess, like from 2 to 4 gigabytes of data. So we will use remote, and we have the option of using a remote GPU. The cost, I'm not sure how much. So basically, yeah, it fills the information, and the good thing about this is that if you go to, let's say, here and the lower part of the screen, lower left, you will find details about your account, and also it will give you the balance. And the cost in this case is $0.05 per minute of using the model. So if you use for an image, basically you will imagine it's like really cheap. And for training, that I will cover in another video, it's like $0.005 per step. So I will totally recommend doing this. I will leave in the description some more information about this, but if you click on subscribe, and if you comment, you make a comment, I can give you credits. I have 5 codes, so you can redeem credits up to $50 each. So you can see that you can use a lot of cloud processing with that kind of money. So what other models do we have? Let's see about this. Edge detection, for example. You have like things like, I don't know, like brutalist architecture generator. I'm not a huge fan of those. We have edge detection, which is also, again, like really useful for architecture students. So as an input, you can select your camera or a file, for example. This is me. And if you process this, if you click run remotely, you will see that this will take a while because it's sending the information. Now we are sending video from my feed to the web, and as you see, it does a pretty good job. I mean, if you use an image, for example, it will give you the result like really fast. Now this is processing like frames per second, so and actually the frame rate is quite okay, but you see you get a really clean image. The lower the resolution of your camera, the faster it will work. So you can change the parameters here on the right part. If you increase it, you will get like finer results. I will recommend like increasing this if you're using videos, if you're using pictures instead. You can play, of course, with the settings of your camera, like saturation. So for example, I can get rid of color information. So you can of course always like apply some filtering to basically fine-tune the edge detection of what you're doing. This brightness, for example. So you see it produces like different results. To finalize this video, I will stop this. We will try, I will show you the last one, that is pose estimation. So let's filter that category. So we have motion capture. There is this one that is called PoseNet. It's a human pose estimation, or we can use the detect facial features. For now, we will use pose estimation. And if you select the camera as your input, and you can run this locally, or actually you can only run this locally, so that's good. You won't use credits for this. You can see that right now this is using machine learning to detect my skeleton. So basically it detects the position of my hands, the position of my eyes, my nose, my ears, even though it's not looking at my ears, where my shoulders are, where my arms are. So if you're working, for example, in an interaction project, this is actually quite useful. Or if you want to, let's say, analyze people in the space, it can detect up to 20 people in the room. So it will detect, like, of course, like depth. And this is pretty awesome because in the past, you can only do this with like sensors, like 3D scanners, like Kinect, for example, or things like that. Right now, we have the option of doing this with just your webcam. So the last thing that I want to show you about this, because we will use this for the next tutorial, you have network. And the cool thing about this, like, okay, now what do I do with this? I have the prediction, I have the model. How can I use this, for example, in Grasshopper or Rhino? Or even like, I don't know, like processing. I will show you how to do that too. Because this works as a black box. Basically, something enters this black box, it's processed, and it spits something, it gives you something. It has like many ways of interacting with other softwares, like using HTTP calls like socket.io. So basically through WebSockets you can send information. OSC, this protocol that allows you to interact with, for example, game engines like Unity or JavaScript, or processing or JavaScript. Through these protocols of communications, basically through this local server, we will learn how to get information from Runway and input that into Grasshopper to create like interesting things. So stay tuned. See you later.